Hello guys, welcome. My name is Venkatesh Reddy. I am a data analysis and machine learning intern at StarTech Academy. And my problem statement is based on machine learning. So the task is to help John from STA IT Services to create a linear regression model in Python or R to predict the CTC salary of new hires from the data provided. STA hires hundreds of IT executives and managers for their consulting business. John's team invests a large amount of time and effort in analyze each and every resume to calculate the joining CTC salary for the new hires. John has recently completed a course in analytics and machine learning, and he thinks that STA can use machine learning to use past data to create data-driven process for setting of CTC salary for new hires. And here we need to predict the salary for the new hires, and we are provided with the two files. One file is data file and other file is test data file. So test data file is the data set which is used to test our model, and we need to find out the mean square value, and also we need to predict our model accuracy. So this is the problem statement, and we need to provide the solution, and the solution is here. And we have used Jupyter Notebook for implementing this solution, and we have used Jupyter Notebook as our IDE. So first we need to import the required libraries for data pre-processing and plotting to understand the data. We have been imported NumPy, Pandas, Matplotlib and Seaborn, and we need to import the required functions from the sklearn. Sklearn is a machine learning library we need to use. So we have imported standard scalar, metrics and mean absolute error and mean squared error. And the next step is to load the data sets of the train and testing data. And those files we have been converted to CSV from Excel. We can use any online converters, or we can use from Excel, we can convert to a CSV file. And after loading of data sets, we need to just view the data whether it is in a proper way or improper way. So we have displayed the first 5 rows of both trained data and testing data using the head function. And using the info function, we can see how many null values are there, or what type of data type is used for storing that object in our trained data. And here we are checking for the null values. And next we are checking for the duplicated rows. So if there are any rows are duplicated, it gives there some how many number of duplicated rows. And next we are getting the summary or statistical information of trained data using describe function. It means it gives the count, mean, standard deviation, minimum and 25th percentile value and remaining all these. And next, after describing our data, we need to create dummy for categorical variables and converting categorical variables into numerical variables. Generally, the categorical variables are yes or no, this type. We need to convert them to integers like 0 or 1. So it is very easy to convert by using the getDummies function from pandas. So we can convert it into numerical variables. And now we are displaying the first 5 rows of the trained data after creating dummies. And here you can observe that we have created the dummies for the category variables. And now we are displaying the columns of our trained data set. And here we are converting our data into normal form, that is the CTC variable. Here you can observe it is separated, or it is involved, it is of a string type and it contains the comma character. Basically it is a float value, we need to convert it into float value, but it has comma, so we need to remove that comma by replacing the comma with an empty character. And next we have converted the string type into float data type. So you can notice the changes that we have converted. See, there are no commas and it is of float data type. And now we are dropping the unwanted dummy variables in our trained data. So for three categorical variables, that is, it requires only two dummy variables. There is no need of third dummy variable. So that's why we removed unnecessary dummy variables in our trained data. And next, the modifications reflected in our trained data columns are clearly shown here. And here we are also dropping some other unnecessary variables in our test data. And after all these modifications and pre-processing work done, we need to display how our data exists in our trained data and test data. And we have here set our index to serial number, and in place equal to true means it modifies the original one, and we have displayed again. See, you can observe that serial number is the index, and rearranging the columns for test and trained data. So the data in which both the trained data and test data are not in a particular order, that is the columns are not in a particular order, so we need to make them to arrange in a particular order so that the client or some other fields very easy to understand. And here we are setting and we are checking that our columns are in a same order, both trained data and test data. And next we need to divide the trained data into dependent and independent variables. Here we are predicting the actual CTC. So here actual CTC is an dependent variable, and it is the final value that we need to predict, and remaining variables are independent variables, and the value and those variables are used to predict the actual CTC. So we need to split the data into dependent and independent variables in both trained and test data. And after that, we need to transform, or we need to standardize the trained data and test data of x-axis. That means we need to convert the independent variables into some standard form using standard scalar function from SQL under pre-processing. And here we are displaying that you can see that the data is converted into standardized normal form. And now we will use linear regression model for this problem statement. So we have imported linear regression from sklearn library, and we have created a model, and here we have fitted the data into our model. And next we have been predicting our model using the test data. So you can see that the values of this, and now we need to evaluate the performance of our model. So we have been used R2 square function, and it takes the parameters of our y predicted and y test variable data, and it shows that 0.60. It means nearly 60% or 61% is the accuracy of our model. So here you can observe it, and the mean average error and the mean squared error also you can observe that root mean square error. And this is the solution for the problem statement of salary prediction. And thank you StarTech Academy for providing this internship opportunity to us, and really it's very pleasure to work with you, and thank you.